Before we try to find how to inverse a function, we need to figure out whether the function has an inverse. An inverse function, you see, reverses the operation done by a particular function. In other words, whatever the function does, the inverse function undoes it. So, what are the conditions for the function to be able to have an inverse? As an example, let's assume that a function f, which we'll denote as fx in yellow, has a domain with a range of values and a range with the following y values. And in the inverse function, if it exists, and we'll denote that as f to the minus 1, we'll have the domain which used to be the range of the function of fx. And the range of the inverse function be the domain of the function of x. In other words, the range of the inverse function is the domain of the original function, and vice versa. Having said that, I'll need to say that the inverse functions are not always possible unless the original function is 1-to-1. And now I'll probably have to introduce to you what I mean by a 1-to-1 function. So what is a 1-to-1 function? A 1-to-1 function has to undergo a horizontal line test. According to the horizontal line test, the horizontal line cannot intersect the graph more than once. I'll illustrate this by drawing two different functions. One of them I have chosen to be fx x squared. This is a parabola function. And if I was to sketch that parabola function, which is usually just simply this way, it is symmetrical. The other function that I'll illustrate is fx, and I'll make it a cubic. Its left hand side looks slightly wilted. Using a ruler, I'll draw a number of horizontal lines across in various places to both of the functions. And this way I can determine whether my horizontal line intersects the graph more than once. Well, you can see in here where I'll put a cross that in the very first function it intersects it twice. Here it intersects it twice. Here it intersects it twice. Whereas the cubic function, it always intersects it in one place. So we can see which one failed the test. This one failed the test, and this one did not fail the test, and we call the cubic function can now be called 1-to-1. Therefore, it will have an inverse. And now that we've determined whether the function has an inverse, I'll show you how we find the inverse. So, how do you find the inverse of a function? There are 4 steps to this. Let's start with example 1, where function f is defined by 2x minus 1. And we want to find the inverse function. And we'll start with step 1. Very simply, we just replace the fx with y. So we make this into 2x minus 1. Now step 2 is swap the x's and the y's. So where I've got y, I'll make it into an x, and where I've got x, I will exchange it for a y. The third step is probably the longest one, because you're going to have to try and solve the equation for y. We need to make y the subject. So I will move the 1 to to the left hand side and leave the 2y on its own. And now I can divide both sides by 2, and I'll have x plus 1 divided by 2, and my y is on its own now. And rearrange it so that y is now the subject. Y is x plus 1 over 2. The last step is the easiest, but it is the most important one. Now you need to replace the y with f to the minus 1x, because that means the inverse is equal to x plus 1 over 2. You might have already guessed that we put that minus 1 here to imply that this is the inverse. Now I'd like to show you what does an inverse function look like on a graph. So let's start with fx is 2x minus 1. 2x minus 1 will be a straight linear line with a gradient of 2, and so it's just a straight line. Y is equal to 2x minus 1. Now to find the inverse, we'll draw another line. This time our line is going to be y is equal to x. Why are we drawing y is equal to x? Because if we do a reflection of our blue line in y is equal to x line, we'll get an inverse of our function, which will be y is equal to half x plus a half. Because our inverse function was x plus 1 over 2, which is the same thing as saying a half x plus a half. So graphically, an inverse function is the reflection in the y is equal to x function. I'll just do one more example. This example will be find the inverse of ln x minus 2. The very first thing that we're going to do is number 1, and we're going to swap the fx with the y, so that's y is equal to ln x minus 2. Now number 2, we're going to swap the x's and the y's, so this becomes x ln y minus 2. And number 3, step 3, we will need to solve for y. And for this step, we will e both sides. And so e to the x is equal to y minus 2. So y is equal to e to the x plus 2. And step 4 is to show that inverse of x is equal to e to the x plus 2. Now I'd like to show you the graph of these functions. The blue was ln x minus 2, the original function, and then we had the y is equal to x line, which will show the reflection of my inverse function as being e to the x plus 2. This is my inverse function. If you are interested in seeing a lot more examples, then please let me know in the comments and I will publish them as soon as I can. And I hope that you found this useful. Please subscribe to my channel and put the thumbs up. Thank you.